Okay, so now I will be going over question 30. So the first important concept in question 30 is work. Okay, so the equation for work is equal to the force times the distance it travels. So force times distance equals work. And so also we can define force as equal to mass times acceleration. So then if we substitute that in, we can say that that work is equal to, put in mass times acceleration here, mass times acceleration, which is force, times distance. So this can help us with m times a times d. So work is also equal to m times a times d, mass times acceleration times distance. Okay, so that is going to be important when solving this question. The other concept I'm going to go over is the kinematics equations. So I've explained this before, but basically kinematics is looking at motion, so like velocity, acceleration, displacement, without looking at force and what caused that motion. So it's basically like a simplified version before getting to the more harder concepts, like why that motion occurred. And so there's various kinematic equations, but in terms of this problem, I'm going to be using the equation, kinematic equation velocity final is equal to the initial velocity squared plus 2 times the acceleration times the distance, or displacement. Okay, so now I'm going to read question 30. How does the work required to accelerate a particle from 10 meters to 20 meters compare to that required to accelerate it from 20 meters to 30 meters? Okay, so to do this, I'm going to break it up. I'm going to find the work required to accelerate it from 10 to 20, and then compare it, and then do it from 20 to 30, and then I'll compare them, and based on the problem, see if it's less or more or the same. Okay, so first we're going to go from 10 to 20 meters per second and see the total work there. So what I'm going to do is I'm going to plug the values I have into this kinematic equation. So from 10 to 20, the velocity final is going to be 20. So 20 squared is equal to the initial velocity, which is 10 squared, plus 2 times acceleration times the displacement. Now, as I've shown above, work is equal to mass times acceleration times distance. So that means that right here, this is what I'm solving for. This will give me work. So I'm going to basically solve for this here. So 20 squared is 400 equals 100 plus 2 AD, subtract, I get 300 equals 2 AD, divide by 2, and I get 150 equals AD. So that's the work from 10 to 20. Okay, so now I'm going to go from 20 to 30. Okay, so 20 to 30. So I can plug everything in. 30 equals 20 squared, 2, and then this is what I'm solving for, AD, because it's the work. So 30 squared is 900 equals 400 plus 2D. I can subtract, and I get 500 is equal to 2AD. And if I divide by 2, I get that 250 equals AD. So here. And if I'm comparing, I can see that going from 20 to 30, the work is greater than the work required to go from 10 to 20. So that tells me that the correct answer to this problem is A. It is less, showing that from 10 to 20 it requires less work than from 20 to 30. So I'm going to write A. That is the correct answer. So in conclusion, this question shows important concepts of work, specifically that I can say work is equal to mass times acceleration times distance, because of force is equal to mass times acceleration. And it shows how I can solve for that in a kinematics equation, and also how I can use kinematic equations to solve a question like this.